In this lesson, we're going to talk about proving triangles are congruent. So don't be scared of the word proving. We are going to eventually do proofs, but we'll start with giving you the rules you're going to need to write those proofs. So we'll first talk about congruent triangles. The definition of the word congruent means that they're the same shape and the same size. Same shape, same size. So if we put one on top of the other, they would be identical. So we're going to start talking about their corresponding parts here. We're going to pair vertex D with vertex Z, because they're the same measure, and vertex E is going to go with vertex J. Because D, F, and OZ are both 9, so they're going to pair together, so that means E and J would. D, F, and blank are corresponding sides. DF, I'm going to say ZO. Now, if I have said OZ, it would be the same thing. EF and blank are corresponding sides. EF is going to go with JO. And again, I could have said OJ, and it's the same segment as JO. The order of those letters doesn't matter yet. What reason supports the statement that angle D is congruent to angle Z? I'm going to have to go with you gave it to me. So we're just going to write given. Remember, in a proof, we're going to have certain information that's just given to us. And this is that piece of information. Is the statement triangle DEF is congruent to triangle ZJO? Who picked those letters? Is that correct? Well, I don't know. I don't know. Are all the sides equal? I only know these two. Are all the angles equal? I only know those. So I'm going to say, I don't know. But let's check and see if the letters correspond correctly. I think that's what they want us to look at. If I said DEF, would that correspond to ZJO? Yeah, those letters correspond. So I'm going to go ahead and say yes, because the letters correspond correctly. What did they do in this next one? They said OZJ. OZJ. And then they said FDE. Did those letters correspond correctly? Well, O goes with F, Z goes with D, and J goes with E. So that's also a yes. What if I had said triangle DEF and triangle JZO? Would that work? Look at the order of the letters. Does D correspond to J? No. So this one doesn't work because the letters don't correspond. So when you're writing the names of your triangles, the order you put the letters in matters a lot. They have to correspond. The first letter must correspond to the first letter. All right, so we have 4 rules that we're going to learn today for proving that triangles are congruent. We're going to start with one called SSS. The SSS theorem says that we must have 3 pairs of congruent sides in order to prove that the triangles are congruent. So in this picture, I must prove that DE is parallel to RU. I must prove that EF is I said parallel, I meant congruent. I must prove that EF is congruent to UN, and that DF is congruent to RN. If I want to use this rule that we call side, 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 I have to have 3 pairs of congruent sides. And then if I know that all of the sides are congruent, I could say that the triangles are congruent. So that's one way. If I know about all the sides, if all the sides are congruent, then all the angles are going to be congruent too. All right, next up we have a rule called SAS. This one is called side, angle, side. Now I'm going to be really specific in this one is I'm going to write included angle. So for number 8, we have to have two sides, and then we have to have included angle. And I'll show you what that means. So for this particular one, they said DE. We already have DE and RU. DF and RN. I'll just write over those with the blue pen. Now when I talk about this included angle, do you see these two sides? They meet at angle D. Angle D is included between the two sides because that's where they meet. Over here, see these two sides? R is included because it's in between those two sides that meet. So I need those three things, two sides and the angle that's included. I can use this rule called SAS, side, angle, side. I'm going to draw a new set of pictures so I can label them for number 9. So here's what angle 9 says. If we want to use a rule called ASA, well, one's angle, and I'm going to write the word included side, angle. So ASA, angle, side, angle. And this side has to be included between the angles. So we know in our picture, angle E is congruent to angle U. They correspond. Angle F is congruent to angle N because they correspond. Now the question would be which side is included between those two angles? Well, it's angle E and angle F, so I think side EF is the one that is included. Over here I have angle U and angle N. I'm going to go with side UN that is included between the two sides. So when we have the two angles, the two letters of the angle make up the name of the segment. So angle E and angle F make up, or angle side EF is included between those two angles. So that's the angle side angle postulate or theorem. We'll just call it a rule. Let me do one more set of triangles so I can label number 10 for you. And then we'll practice seeing what this looks like. Please ignore the fact that these two triangles are nowhere close to congruent because I can't draw. Alright, this one's called AAS. So it's still got two angles and a side, but look at the difference. It's not angle included side angle. This one's angle, angle, side. And the side in this one is not included. So angle, angle, side. The side that's not included. So let's label these. Segment FD is congruent to segment NR. Now they told us right here we're going to use angle F and angle N as one of our angles. Now I want the angle that doesn't make the side included. So if I use D and R, then I'm duplicating angle side angle because R and N include segment NR. I want the angle that doesn't include this segment. So I'm going to go with angle U and angle E. And now I have angle, angle, side that's not included. As opposed to here, I have angle, angle, and the side that is included. So these are the two that people struggle with the most. They're trying to tell when is it ASA, when is it AAS. If your side is named by those two angle letters, it's included. if your side is not named by the two angle letters. So this is side FD, this is angle F and angle E, then it's angle, angle, non-included side. So our 4 rules that we're going to use to prove that triangles are congruent. We're going to go to the next page and look at some pictures and see how this works. So just for reference, I'm going to write the rules that we have to use. SSS, SAS, ASA, and AAS. Please notice there is no SSA or ASS. Not just because I don't want you to write that word on your paper, but because it doesn't make the triangles congruent. And we can go into greater detail if you want a little tutorial on that later, but just know that SSA does not exist. Use it, it's wrong. You're funny writing ASS on your paper, but it's wrong. So don't do it. You won't get any points for it. So be careful there. All right, take a look at the first picture. So I noticed they've given me angle A and angle E, and given me those 2 sides. But all of these theorems require 3 things, and I'm missing one. So if you look carefully, you might remember this angle and this angle. Those are our vertical angles. So when you see a picture like this, I like to call it the bow tie picture, because if you look at it sideways, it looks like a bow tie. Always look for those vertical angles. I'm going to write a note there because we're going to need this in proofs later. Vertical angles are congruent. You're going to be using that reason in your proofs next class. So let's decide which one of these rules it would be. Well, I've got 2 angles and a side, so it's one of these 2. Is the side included in between the 2 angles, or is it not included? Well, the angles are E and C, and this side is CD. It's not the same 2 letters as the angles. So this one is not included. Angle, angle, side. And we could write a congruent statement because we have letters, but not all of them have letters, so we'll just worry about the theorems for now. Let's look at the next picture. I have these sides that are marked congruent. Got little boxes here. Remember what those boxes mean? Those boxes tell us that these are right angles. And I can't remember if we've given you the rule, but we're going to use it a lot. Right angles are congruent because this is 90 and that's 90, so there's a rule that says right angles are congruent. But I still only have 2 things. I have a side and an angle. Here's what I'm going to notice. See segment YZ? It's in the left triangle. See segment YZ? It's in the right triangle. So YZ is in 2 separate triangles. So I'm going to say that YZ is congruent to YZ. And see if you remember the property for this one. Everything is equal to itself. That's the reflexive property. Because YZ is shared. It's part of both pictures. So we say the YZ on the left side equals the YZ on the right side. Reflexive property. You're going to use this one a lot. It's going to be your favorite because it's super easy. All right, let's look at number 13. Well, number 13's got stuff labeled for me. If I look at this picture on the left, I see a side, an angle, and a side. And the angle is included between the 2 sides. So that one looks like an SAS. Well, let's see if the second one matches. On the second one, I've got the angle and the side over here. That's not the same, is it? This side with the 2 marks on it isn't in the same place as that one. So because my parts don't correspond correctly, we're going to say none. I can't use any of my 4 rules because they don't match. So they said to write a reason, we'll just say they don't match. So either that's a typo or someone did it on purpose, that the side with the 2 hash marks doesn't match. So we're going to say we don't know if it's congruent. Take a look at number 14. Well, they labeled these angles for us, and this one looks just like number 1. The numbers are really off here, aren't they? I think that was supposed to be number 11. So number 14 is just like this one. It's got the vertical angles here. So which one of our rules can we use? I've got 2 pairs of angles, so it's either ASA or AAS, but aren't we missing a piece? There's no sides labeled congruent. So none, we'll just say not enough info. I need another piece of information to decide if my triangles are congruent. They're similar because we have a but we haven't met these 4 rules. All right, let's take a look at the next one. Let's see. I see 2 angles because remember right angles are congruent. Oh, right there. And reflexive property here in the middle. So I have 2 angles and a side. Is it the included side or the not included side? Well, look at one picture at a time. Angle, angle, side. You look at this picture. Angle, angle, side. So I'm going to use the AAS because this side isn't the one between the 2 angles. All right, next picture. Looks like I've got a hash mark on PR and RT. These angles are congruent. And do you see the bow tie? These angles are congruent. So I've got an angle, a side, and an angle. Is the side included between the 2 angles? Remember, angle R and angle T, segment RT. If your segment uses the same letters as your angles, it is included. So ASA. All right, number 17 has labeled nothing. Nothing at all. Ooh, I do see vertical. I'm sorry, reflexive. The one in the middle is reflexive. But all they gave me were these arrows. Seems to me those mean parallel. And we had a lot of good information about our parallel lines. One in particular says that if my lines are parallel, the alternate interior angles are congruent. And if these 2 lines are parallel, I've got another pair of alternate interior angles that are congruent. So now I'm looking at angle, side, angle. So whenever you see parallel lines, think about your alternate interior angles. Sometimes it's corresponding, but 90% of the time, its alternate interior angles are congruent. If they give you parallel lines, you're supposed to pull out some congruent angles. All right, next up, I see a reflexive property, and I see a couple of angles, and that's it. Not enough information. We need 3 pieces of information, and this one doesn't have it. All right, next. So if you look at your picture, you should see reflexive. We've got these sides, and we've got this angle. So I'm going to look at one picture at a time. I've got 2 sides and an angle. Is the angle in between the 2 sides? Is it where the 2 sides meet? Yes. And the same thing on this picture. So we're going with SAS. So the angle is included if it's at the corner where these 2 congruent sides meet. Next up, they've got some angles labeled for us. I'm going to put A's on these angles. And then notice we have a shared side, UW, in the middle. So that's my side. 2 angles and a side. Is the side in between the 2 angles or not included? So it's angle, angle, side. Next up, These sides are congruent. These sides are congruent. And by now I hope you're seeing the reflexive property. JA is shared in both triangles. So we're looking at the SSS theorem. And last one, again reflexive, right here on AC. Then you can look at side, angle, side, side, angle, side. They both match. So we didn't give you an example of the one that doesn't work. I can show you that one. So I could give you this and this. That's all the information you had. Well, I know I have a side here, have another side here, and there's an angle. So in order to have an angle, it has to be AS, side included angle side. So I look at my picture. Here's my sides where they meet. Is the angle where the two sides meet? It is not. So this would be SSA, which is not a method for proving triangles congruent. So be on the lookout for that SSA, because that's a no-no. That does not prove triangles are congruent. Only these four. Side, 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 angle, side, angle, side, angle, and angle, angle, side.